Welcome to Curious Minds English.
Hey everyone, welcome back to our YouTube English listening podcast.
Hi, guys. It's great to see you again. Thanks for spending time with us today.
If you are new here, this channel is an easy English podcast about science, nature, history, and life.
We talk slowly, we repeat important ideas, and we use simple words so you can relax, listen, and learn English.
If you like this style, please like the video and subscribe to the channel.
And turn on the notification bell so you do not miss our next science story in easy English.
Today's topic looks very simple, but it is actually very strange.
Let me guess. Is it about space or black holes or something big like that?
No, it is something you see every day. You drink it, you wash your hands with it, you cook with it.
Oh, so we are talking about water?
Yes, water looks normal and boring, but in nature, it is one of the most weird things.
Really? It looks so simple. It is just clear, wet, and cold.
Many scientists say water is very special. It does things that most other liquids do not do.
Okay, now I'm curious. What is so strange about water?
In this episode, we will answer three big questions about water.
3 questions. Nice. That is good for English learners, too. Easy to remember.
First, why is water so important for life? And why does ice float?
Second, what happens if you try to keep fish in hot water like warm soup?
And third, why is rain mathematically almost impossible, but in real life it falls all the time?
Wow, that sounds fun. Let's start with the first question.
Okay. Question 1. Why is water special for life? And why does ice float on water?
I always see ice cubes floating in my drink. It feels normal. But maybe it is not normal?
Right. For most substances, when they become solid, they get smaller and heavier.
So the solid form usually sinks, right?
Exactly. When something gets cold, its particles move less. They come closer together. The volume becomes smaller, and the solid can be more dense.
But water is different. Ice is bigger for the same mass, so it is less dense and it floats.
Yes. And this simple fact helps life on Earth. But to understand it, we need to look at water molecules.
Molecules are the tiny parts that make up a substance, right?
Yes. One water molecule has one oxygen atom and two hydrogen atoms. We can write it as H2O.
Many students know H2O from school.
In a water molecule, the oxygen pulls the electrons more strongly than hydrogen.
So the molecule has a plus side and a minus side, like a tiny magnet.
Exactly. The hydrogen side is a little bit positive. The oxygen side is a little bit negative. So water molecules can stick to each other.
Is that what we call a hydrogen bond?
Yes, a hydrogen bond is a weak bond between a positive part and a negative part of molecules.
So how does this make ice bigger than water?
When water's liquid, the molecules move a lot. The hydrogen bonds break and connect again and again. It is a little messy.
Like people walking in a busy station. Everyone moves, sometimes close, sometimes far.
Good example. But when water gets very cold and becomes ice, the molecules stop moving so much. They make a stable pattern like a careful crystal.
So they line up in a special shape?
Yes, they form a kind of open, six-sided structure, a bit like a snowflake. This structure has empty spaces inside,
Ah, so the empty spaces make the ice take more space, but the mass is the same.
right? The volume is bigger, the density is lower, so ice floats on water.
Okay, I get the idea. But why does this matter for life?
Think about a lake in winter. When it gets very cold, the top of the lake freezes first.
The ice stays on top. It becomes like a lid.
Yes, under the ice, the water is still liquid, and near the bottom, the temperature is around 4 degrees Celsius, which is comfortable for many living things.
So fish and other animals can stay alive under the ice layer.
Exactly. If ice were heavier and sank, the entire lake would freeze from bottom to top. Many living things would die.
So ice floating is one secret reason life can survive cold times on our planet.
There is another interesting point. Very cold things can also hurt cells in our body.
You mean like when something is frozen and it breaks?
Yes. For example, dry ice is frozen carbon dioxide. If you touch it with your hand, it can damage your skin like a burn.
But it is extremely cold, not hot. Why is it like a burn?
Inside your skin cells, there is water. If it freezes very fast, the water expands and can break the cell from the inside.
So the burn is actually from ice crystals destroying the cells.
Exactly. This shows again that water's expansion when it freezes is very powerful.
Okay, I did not know ice was such a hero and such a troublemaker at the same time. What about the second question?
Question 2. What happens if we keep fish in very warm water?
My first guess is they will feel relaxed, like people in a hot spring.
For a short time, some fish might move more and look active. But if the water gets too warm, they can die.
Oh no, why?
First, we need two words: warm-blooded animals and cold-blooded animals.
Warm blooded animals keep their body temperature almost the same all the time. Humans and birds are like that.
Right. Cold-blooded animals like fish and many insects do not control their body temperature much. Their body temperature is almost the same as the air or water around them.
So, when the water is cold, the fish's body is cold too. When the water is warm, the fish is warm.
Yes, when the water gets warmer, the fish's body works faster. It swims more, digests food faster, and uses more energy.
That sounds good. More energy, more action.
But there is a big problem. Fish do not breathe air directly. They use gills to take oxygen from water.
Right. So, the amount of oxygen in the water is very important.
Here's the key point. Warm water holds less oxygen than cold water.
Really? So, there is more oxygen in cold water?
Yes. When water gets warm, gas molecules like oxygen move faster and escape into the air more easily.
Ah, that is why warm soda loses its gas and tastes flat so quickly.
Exactly. Warm soda cannot keep the carbon dioxide gas inside, and water cannot keep oxygen so well when it is warm.
So, in warm water, there is less oxygen for the fish.
Yes, but remember, the fish is more active and needs more oxygen at the same time.
That is like running fast while the air around you suddenly becomes very thin.
Good image. So the fish use more oxygen but get less oxygen. They can quickly suffocate in very warm water.
So, fish do not like very cold water or very hot water. They need a good balance.
Exactly. And again, Water's behavior with temperature is very important for life. Oceans and big lakes change temperature slowly, so the animals have time to adapt.
This is really interesting. Now, what about the third question? The rain one.
Question 3. Why is rain almost impossible in theory, but easy in the real world?
That sounds like a paradox. What do you mean?
We know the basic story. Water from oceans and lakes evaporates. It becomes water vapor in the air. Then the air rises, cools down, and the vapor turns back into tiny drops.
The tiny drops collect and we get clouds and rain.
Yes, but if we think only about water molecules in empty air, it is very hard for many molecules to come together and stay together as a drop
Why is it so hard?
because of something called surface tension.
I heard that word before, but I do not really understand it.
Surface tension is the force that makes the surface of water act like a tight skin.
Oh, like when you fill a glass almost to the top and the water is a little bit higher than the edge, but it does not spill.
Exactly. The water molecules pull each other and try to make the surface as small as possible,
So water likes to make round drops because a round shape has a small surface area.
right? Now, think about a very small drop of water in the air. The surface is big compared to the inside. Many molecules are on the outside, and they are not so stable.
So the tiny drop can easily break apart again.
Yes, to make a stable raindrop, many molecules must come together at the same time. Mathematicians say that this is extremely unlikely if there is nothing else in the air.
But we see rain often, so something must help the water drops.
That something is dust and tiny particles in the air. We call them condensation nuclei.
Condensation nuclei, so little pieces for the water to sit on.
Yes, water molecules stick to these tiny particles. It is much easier to make a drop around a little piece of dust than from empty air.
So every raindrop has a tiny bit of dust or something like that inside?
Yes, in many cases.
That means really clean air might actually have less rain.
Exactly. In places with very clean, dry air, it is hard for water to find something to stick to, so there is less rain or snow.
Wow. So rain is not just pure water from the sky. It is water plus a tiny center of dust.
So today we saw three strange things about water.
First, ice is bigger and lighter than water, so it floats and protects life under the ice.
Second, warm water holds less oxygen, so fish can die in water that is too hot.
And third, water needs dust and small particles in the air to make raindrops. Surface tension makes it hard to form drops without them.
Let's go over a few useful words from today.
Good idea. That helps English learners a lot.
The first word is molecule. A molecule is a very small part of a substance. For example, one water molecule is H2O.
You can say a water molecule is small, but many water molecules together can make an ocean.
The next word is surface tension. It is the force that makes the surface of water tight and small.
For example, because of surface tension, a small insect can walk on the water without sinking.
Another word is float. It means to stay on top of a liquid.
The ice cubes float on the water in my glass.
We also use the word oxygen. Oxygen is a gas in the air. Humans and fish need it to live.
Fish take oxygen from water through their gills.
And lastly, survive. It means to stay alive in a difficult situation.
Because ice floats, fish can survive in a lake even in winter.
Great. I hope these words are clear now.
Yes. And if something is not clear, you can always replay the video and listen again. Repeating is very good practice.
So, how did you feel about this topic, Jessica?
I liked it a lot. Water looked boring before, but now it feels like a superhero for life on Earth. It protects lakes, helps rain, and also decides if fish can live or die.
I agree. Sometimes the most common things are the most amazing.
If you enjoyed this easy English science story, please like the video, subscribe, and share it with a friend who is learning English.
And tell us in the comments, what other simple things in daily life do you want us to explain? Maybe air, fire, time, or something else?
Thank you so much for listening today.
See you in the next episode.
Bye, everyone.